Hi, this is Mrs. Barbara. This is Physics Chapter 12, Sound and Light, Video 6. Today's topic is total internal reflection. The objectives are: know the definition of total internal reflection and the critical angle. Understand conditions of total internal reflection. Be able to determine critical angle, index of refraction using Snell's law. Be able to give examples of total internal reflection in everyday situation. Total internal reflection is complete reflection of light at the boundary of two transparent media. This effect occurs when the angle of incidence exceeds the critical angle. Take a look at light over here. Now, here, this is the critical angle. When exceed the critical angle, all the light is reflected. So let's take a look from the beginning. Here is just refraction, critical angle. Okay, then total internal reflection happens. Same here. Here is just picture the refracted ray become dimmer. There is less refraction. Here is going from denser to less dense, refracted, getting dimmer and dimmer, and the reflected ray becomes brighter and brighter. Eventually, all the light is reflected. That's called a total internal reflection. Critical angle is the minimum angle of incidence for which the total internal reflection occurs. So in this case, this is critical angle I. So what is critical angle? Critical angle is the angle of incidence when the angle of refraction equals to 90 degrees. So the corresponding incident angle is called critical angle. Critical angle, when incident angle equals to critical angle, the angle of refraction equals to 90 degrees. So here is N1, medium 1, here is medium 2. So this particular value of the angle of incidence could be calculated using Snell's law. N1 sine theta 1 equals N2 sine theta 2. That means N1, when theta 1 equals critical angle, theta 2 equals 90 degrees. So we can find the critical angle is inverse sine of N2 over N1. For example, a laser beam is shining from water into air. What is the critical angle of water? So here is N1 from water, that's N1, here is N2. So what is theta 1? Critical angle is the angle of incidence when the angle of refraction is 90 degrees. So theta 2 equals 90 degrees. N1 is water, N2 is air, theta 2 is 90 degrees. What is theta 1? So that's inverse sine N2 over N1, you'll have 48.7 degrees. What does that mean? So when the angles of incidence is greater than this angle, 48.8 degrees, all of the energy carried by the incident wave to the boundary stays within the water, will be totally reflected and undergoes reflection of the boundary. So nothing is transmitted, all the waves are reflected. Let's take a look of a few examples. The critical angle is the angle of incidence. Okay, that's when the angle of reflection equals 90 degrees. Critical angle causes light to cross the boundary without refracting, undergo refraction at the same angle as the angle of incidence, or refract at an angle of refraction of 90 degrees. Yes, that's the definition of a critical angle. So the answer is C. There are two requirements for total internal reflection. First one, the light is in the denser medium and approaching to less dense medium, such as going from water to air. The second one, the angle of incidence has to be greater than the so-called critical angle. If the angle of incidence is less than, that means some of the light is going to be refracted. Total internal reflection is sparkle of diamonds. So relatively speaking, the critical angle for diamond air boundary is an extremely small number. So this property about diamond air boundary plays an important role in the brilliance of a diamond gemstone. So So having a small critical angle, light has the tendency to become trapped inside a diamond once it enters. So once it enters, it will refract. But once it's refracted, it will go through multiple of internal reflection. That's why diamond looks so brilliant. Other examples of total internal reflection. So we actually do use total internal reflection for communication. So a lot of cables we use are total internal reflection. So we also use for instrument in medicine, we use in periscopes, we use other optical equipment. So one advantage of total internal reflection is total, and there is no energy loss. So 100% of the light is reflected, unlike a mirror. For a mirror, only maybe like 95% is reflected, and the other 5% is lost or absorbed into other forms of energy. But for total internal reflection, all the energies are reflected. Okay, next one, rainbow. I'm sure everybody have seen the rainbow before. Rainbow is produced by refraction and total internal reflection. How it forms, it's pretty complicated. This is a gist of it. When the sun, in order to see the rainbow, sun has to be behind you and water has to be in front of you. So the sunlight comes to the rainbow at certain degrees. These are the water drops. So remember, refract, different color of light refract differently. So red light bends the least, violet bends the most. So when they reflect, so they become separated. And at the end of the inside the water drop, the light is totally internally reflected. So it will go through total internal reflection, comes to this boundary, when it comes out, is separated even more. So again, violet is on top. Because it's on top, this violet is not going to reach your eye. What's going to reach your eye is the red light is going to reach your eye. But there is another water drop over here. So in this water drop, the violet is going to reach your eye. So from how you see, is the violet is on the bottom and red is on top. So the top of the rainbow, the bottom of the rainbow. Even though violet is supposed to be on top, but you can't see the violet from the water drop that you see the red. The violet is from the water drops from the bottom. Okay, that's how you see the rainbow, because waters are separated. The colors of light are separated through the water drops. Atmospheric refraction and total internal reflection. This is how mirage is formed. So let's take a look at the video first.
Hello there, this is Shankaran and with me is Pooja. Hi. And we are back with the concept of physics for you, and for that I want you all to look very carefully at the road. Can you see that?
It seems like we are driving in a river.
And you look carefully, as you're going closer, layer by layer is actually disappearing. There goes a layer.
Right.
And see the next layer, right? This is amazing, right? Don't you feel we should understand how exactly this happens? And for that, my friend here, Pooja, is going to take you to a desert.
So, are you guys ready? Now, seeing water on a highway is one thing. But imagine a thirsty traveler traveling in a desert, he sees water. There is nothing more miserable than that, right? Let's understand why this happens. Basically, what happens is, during day, the land becomes hot. Because of that, the air molecules above are warm. But as you go up, it keeps on becoming cooler and cooler. That means, right now, at this level, if I hold my hand like this, I can clearly see the difference. That is, my lower hand is much more warmer in comparison to the above hand, which is much more cooler. So what we have understood is the layer at the bottom is more warmer, but as you go up, it gradually keeps on becoming cooler and cooler. Now, the light from the sun hits the object. The tree there is the object. After hitting the object, the light will reflect and it will enter the first layer. Now, the first layer is denser. Now, as and when the light is going from denser to rarer, it will keep on bending away from the normal. So, at each layer, what you see is the light is bending away from the normal. But at one point, what you'll notice is light will hit at an angle which is greater than critical angle. And at that point, instead of light undergoing refraction, the light will undergo total internal reflection and enter my eye. Now, once it enters my eye, human eye always perceives that light always travels in a straight line. So now I can see the reflection there at the bottom. So the reflection of the tree is there. Similarly, the reflection of the cloud is also seen there, and that appears like water. So that is how mirage takes place. So let's summarize the key points. For mirage to occur, there has to be total internal reflection. And for total internal reflection, there has to be two conditions that needs to be fulfilled. The first one is light should always enter from denser medium to rarer medium. And the second condition is very simple. Light should hit at an angle which is greater than critical angle. So here are some amazing mirages that happen in nature.